All right, in this video, we're going to work through the following problem. It says determine if the described lines are the same line, parallel lines, intersecting lines, or skewed lines. If intersecting, give the point of intersection. All right, so we have these two lines, L1 and L2. These are specified in a different way than the other ways that we've talked about. It's not really the vector format, but more along the lines of the parametric format. They're basically saying x equals 1 minus 2t, y equals 3 plus t, z equals 4 minus t, and so on and so forth here. Okay? All right, so here are the lines, and before we get started, the first thing that we would kind of want to do is to take a look at the direction vectors of each line. So those are going to be the numbers that are the coefficients of the t in the equations. So the direction vector for the first line is going to be -2, 1, -1. And for the second line, it's going to be 4, -2, 2. And the first thing that we want to check to see is if these direction vectors are parallel to each other. So in other words, if they're scalar multiples of each other. Looking at the first component of the first vector, I have -2, and the first component of the second vector is 4. So I would multiply -2 times -2 to get that positive 4. So then 1 times -2 would be -2, and -1 times -2 would be positive 2. And so these things are parallel to each other. At least the direction vectors are parallel to each other. So that means that these two lines are either going to be the same line or they're going to be parallel to each other. Okay. So what I can do is just set up a system of equations like I did before. And remember, you can't use the parameter t, the same parameter on both sides. So just change the parameter to a different letter. Like I said before, if you're using t here, that that implies that the values are going to be equal, but it could be a totally different value of the parameter that makes gives you the intersection points for this line than it is this line. Okay. All right, and so now just pick one of these equations and solve for one of the variables in there. I'm going to pick this one, and I am going to solve for t. So I would subtract 4 from both sides. 3 minus 4 is -1. And then multiply through by a negative, and I get 1 minus 2s. Okay. And I'm going to take that and put it into one of these other variables over here. So I'm going to take t and plug it in over in this first equation. So I have 1 minus 2, and then t is equal to 1 minus 2s. Okay, and so then I am going to start simplifying as much as I can here. And it's lagging a little bit, so just give me a second. So what I would do is start simplifying both sides of this equation as much as possible, distributing that -2 through the parentheses. And then combining 1 minus 2 is -1. Okay, and you can see that if I tried to isolate the s on one side, I would subtract 4s from both sides. That's going to give me -1 equals -1. Okay, and so what that means, right, is that for these two equations that we looked at, there are infinitely many solutions in there for these two. Okay, so if we just pick a value for s, I'm going to pick s equals 0, right? And if I take 0 and plug it in for s, I get into this 1 minus 2 times 0, I'm going to get t equals 1. All right, so that gives me a value for s and a value for t equals 1. So I'm going to go ahead and plug those values in and just check over here. So I have 1 minus 2 times 1. I'm going to plug this value for t equals 1 into L1 and see the point that I get. 3 plus 1 and 4 minus 1. Alright, that's what x would equal, that's what y would equal, that's what z would equal. Alright, and so here I get 1 minus 2 is negative 1, 3 plus 1 is 4, 4 minus 1 is 3. So that's what I would get as the point for that line. And then the value for s, I'm going to plug that into these values right here. And actually you can see I'm going to get the same, right? If I plug negative 1 plus 4 times 0, y equals 4 minus 2 times 0, and z equals 3 plus 2 times 0, like so. Now you can see I get exactly the same values. I get negative 1, 4, and 3. All right, so remember at the very beginning we compared the direction vectors and found that they were parallel to each other, and right there we were able to narrow that down to two cases, right? These lines are either parallel, right, or they are the same line, and we found a point of intersection of these lines, and so what that means is that these are actually the same line, okay? There's nothing special about this solution at all. There's infinitely many solutions, and you might say, well, where did this s equals 0 come from? And once I boiled it down to this equation right here, right, this equation is true no matter what. So that meant that there were infinitely many solutions for these the two equations that I used there, right? So basically I just picked a value for s. If I want to get another point that they have in common, I could pick a value for a different value for s and plug that in. And so these are the same line, okay? So the fact right here, when I boil this down to, when I solve this out, and I got negative 1 equals negative 1, that's a true statement. Remember, in the parallel case, I got 0 equals some other number, which was a false statement. So that meant that there was no solution, and so therefore there were some consequences to that. Here, that meant that basically there are infinitely many solutions. So we just found one, and that eliminated the possibility that these lines are parallel. We knew it was either parallel or the same, so these have to be the same line. All right, and you can see, if you take a look at it, you can see that that when you graph those out, you're going to get exactly the same line in 3 space. Okay. All right, and that is it for this example.